Okay, everybody. I see I got 3 students here. 4. Let me see if some more join in. Okay, all right, I'm going to start. So let me start today by reviewing Unit 9, which is Chemical Kinetics. And in Chemical Kinetics, we had put the standards together. So learning objectives 4.1, 4.2, and 4.3 are around rate laws and orders of reactions. And these are important because these help us figure out how the rate will change if you change the concentration of reactants. And to figure out the order of magnitude by which the rate will change if you change reactant concentration, we write a rate law. And the rate law's general format is R is equal to K, A, if one of the reactants to the power of X, B, other reactant to the power of Y. These are called order of reaction. Remember, in a complete reaction, order of reaction, X and Y have nothing to do with the coefficients of a balanced reaction. These can only be found through experimental ways. And there are 2 ways you can do experimentation. You can use initial rates method. In initial rates, you take different concentrations, but you always measure their rate at t is equal to 0 time. And that is why it's called initial rate. And if you are going to use this method, then the table you will get will have molarity of one of the reactants, molarity of other reactants, and then the rate will be given. And using this, you can eyeball 2 data which are constant for one reactant and see by changing the other reactant, by what factor does the rate change. And remember, in this, we had done one type of problem where the concentration of one of the reactants was never constant. So in that case, we still use the overall reaction, and then we knew the order with regards to one, and we could figure out the order with regards to the other. Go through your packet. We did a practice problem like that. The second type of the second method that you can use to figure out the rate law is called integrated rate law method. In this method, you measure change in concentration of the reactant with time. And you can either use the graphs as you did in your crystal violet lab, where you plot concentration time or natural log of concentration time or 1 over concentration time, and then you see how these graphs change. Or you can use the equations for 0, first, and second order. And the one thing that you need to remember is the first order equation's half-life equation is T half is 0.693 over K, where K is rate constant. And remember, the value of K, the K only changes with temperature. If you keep the temperature the same, then K remains the same, even though you may change the concentration. So that was about order of reaction and then rate laws. And then the second type of learning objectives were on reaction mechanisms. And I will answer the questions once I'm done going over it. So let's go over learning objectives now. 4.4, 4.5, 4.6, 4.7. So 4.4 through 4.7, and these are around reaction mechanisms. In reaction mechanisms, remember guys, reaction mechanism uses all the elementary steps. So if you add up all the elementary steps, then they give you the overall reaction mechanism. Also, in elementary step, you got to remember a few things. If you add all elementary, this color may not be very good, highly visible, so I'm going to change this. If you add individual steps, this, I think this color is no better. Let me stick to black. If you add individual step, then it should give you overall reaction. No elementary step should be more than 3 molecules or termolecular. The slow step should be put in a place where the theoretical rate law mirrors experimental rate law. Remember, we went over all of this, and then we talked about intermediates and catalysts, and you know the difference in them. And you know that the slowest step is also the rate determining step. And here you are often asked to evaluate a mechanism. Is this a valid mechanism for a reaction? And so on. So that was reaction mechanism. The last part of it deals with energy profiles, and those are learning objectives 4.8 and 4.9, and these are energy profiles. And here we will also study the activation energy or the effect of catalyst on rate of reaction. So if you add a catalyst, it speeds up a reaction, and activation energy can be calculated if you plot natural log of rate constant and 1 over absolute temperature, then the slope of the graph is equal to negative EA over R, where E is activation energy, R's value is 8.314 joules per mole Kelvin. And remember the energy profile that we made. If it is multi-step reaction, you'll have that many peaks. The slowest peak will have the higher activation energy, and activation energy is the energy that the reactants have to the amount of energy they need to get to cross the energy barrier. The lower the activation energy, the faster the reaction. And with that, pretty much that is a summary of this chapter. Okay, now I can take your questions. What is that I can answer for you? I'm not going to go over Crystal Violet Lab because I went over it yesterday and you guys did not have many questions in the class today. So I'm assuming that Crystal Violet Lab you guys understood. This was a summary of the entire chapter. Now guys, I can take your questions either from the quiz or from the problem set or any concept question. So you can let me know if you have any questions. Okay, guys, I'm ready. So let's start with the practice quiz. Are there any questions on the practice quiz elements? So I was on a different chat mode and it wasn't showing live chat. So now it is showing it. Talia, you had asked me to write a tad bit lower. So I think after the title, it was taken care of. Am I right? Alan says for 4D, how do we know where the energy profile eventually end up at the end? You don't know that, Alan, as long as you are keeping in mind whether it is an exo or endothermic reaction. Hence, you are keeping the relative positions of reactants and products aligned. You are good with it. Harshita, can you please explain how to do number 2 on the practice test? Okay, Harshita, going over number 2. The half-life of carbon-14 is 55-70 years. How many years will it take for 90% to decompose? Okay, so there are 2 ways of doing it. The best would be, you know that the half-life follows the number 2. So this is practice quiz number 2. So you know half-life follows first order kinetics, right? So natural log of concentration of A at T times minus natural log of concentration of A at 0 time negative KT. Okay, so you know if 90% is decomposed at time T, how much is remaining? 10. So natural log of 10 minus natural log of 100, not 90, because this is at 0 time. You had 100% at 0 time. Negative K, and you can figure out K from 0.693 over K is equal to T half. Or K is 0.693 over T half. And here you have 0.693, and half-life here is in years. We'll leave it in years, 5570, and we will get this, whatever the value here is. And then you put this K, and time is in how many years, right? So time is X, and this K value you can put there. And when you solve it for that, you should get your answer. Please do the problem, Harshita, and tell me if you got it. Karina, do we need to label the graph for the energy profile? And if so, what should be labeled? So Karina, for the energy profile, you just need to label as much information as they give you. So if they give you reactants, you need to label the reactants. If they give you intermediate, you'll need to label the intermediate. If they give you products, you'll need to label that. But generally, they wouldn't ask you to put numbers. But sometimes, remember in a couple of samples from the packet, there were numbers as well. So you will be pretty much guided into writing what they give you. So number 1B, please. I get a different answer for NO order. Okay. So 1B, determine the order of reaction with respect to each reactant. Let me do 1B. So, okay. So you're getting a different order with NO. So let's do NO's order. So for NO's order, we are looking at 2 where Br2 is constant, right? But there is no set of data where Br2 is constant. So we'll first figure out order with regards to Br2. So if you look at data set 1 and 2, what you see is NO is constant, and by doubling Br2, you are about doubling the rate, right? So we know it is first order with regards to Br2. Now we don't know what is its order with regards to NO. So let's put it R proportional to NOx and VR1. So let's look at between first and third. If we now look at between first and third, NO doubles, BR2 becomes 1/2, right? And rate doubles. So what should be the value of X? If it is 1/2 to the power, it's 1/2. If we put it as 1, then this becomes 1. But if we put it as 2, then 2 times 2, 1/2. So this is 4 divided by 2 is equal to 2. So this is second order. Is the answer key not saying second order, Talia? It should be second order with regards to NO and first order with regards to BR2. Yes, Harshita, you can always assume that the half-life problem is first order because 0 and second order have been phased out. So if you get a half-life problem on the AP test or my exam, then you know that this is first order because other kinetics have been phased out. Talia, did you get the answer to this? Okay. Other questions, guys? You're welcome, Harshita. Okay. No problem, Talia. Other questions, guys, on the practice quiz or on the practice problems or concepts in general? Haha, Talia. Yeah, I don't know. Some nifty kids designed it, and then I got very lucky with the sweatshirt. Okay, Manju. Could you go over calculating average rate, instantaneous rate, and initial rate? Okay. So, Manju, here it is very important to understand the concepts. I don't know if they will actually have you calculate because drawing a slope and there could be little variations in that. So they might give you a tangent and ask you to calculate its slope. But I find it highly unlikely that they'll actually have you draw a tangent. But it is good to know the concept. So for average rate calculation, they will give you concentration time data. Like at 0 minute this, 5 minutes, 10 minutes, 15, 20. So for average, you take the difference from the last to first here divided by the difference from last to first. That's because it's the overall change in concentration with overall time. Or if you are given a concentration time graph, then you draw overall tangent and then figure out the total change in concentration with total time. Instantaneous rate will be the rate at a certain point. So if I want to figure out instantaneous rate at this point, I'll draw a tangent of this and figure out the slope of that tangent. And initial rate, you will take the point at initial time and draw a tangent and figure out its slope. So again, to reiterate, I find it very unlikely that they'll have you draw the tangent and find it. They might give you a tangent and have you calculate it. That seems more likely. Did you get that, Manju? Units for 1C on the practice test. So we figured out for in part 1B that R is equal to K NO squared BR to first order. So the units of rate were molarity per second, and that was molarity. So this is molarity per second. So if we write it in terms of K, let me not take shortcuts. If we write it in terms of K, it is R over NO squared times BR2, right? And rate units are molarity per second. This is molarity squared times molarity. Molarity, molarity cancelled out. So it is 1 over molarity square second or molarity negative 2 second inverse. Okay, other questions? No, we did not ignore, Daniel, the units for NO and BR2. Remember, NO's units are molarity squared, so we put it here. NO's here, we put NO's unit here. Molarity with a square. Molarity for bromine here. You don't ignore it. So I put the units for rate, molarity per second, and this is molarity squared and molarity. Molarity and molarity cancel out, hence you have 1 over molarity squared second. We do very much take into account the units of NO and BR2. All right. Other questions? Anybody has any other questions? Karina, which half-lives do we need to know? Can you tell me, Karina? Think. Out of 0, first and second order, which have been phased out. 0 and second have been phased out. That's correct, Talia. 0 and second have been phased out. So you only need to do first order half-life. So if you get a half-life problem on AP exam or my exam, it is first order only. Jocelyn, it's all order integrated rate laws, 0, first and second. We don't have third order in AP Chem curriculum, but 0, first and second are all in curriculum for integrated rate laws. Only for half-life, it is the first order. Otherwise, it is 0, first and second that is in your curriculum. I would say the formative, almost like the formative type, or the practice test is a pretty good reflection, Shravya, for the actual summative. It looks pretty much like your practice quiz. All right. Any other questions, elements? This was a pretty short unit, right? And we practiced quite a bit. I think you guys are doing good. I expect pretty good results on this quiz. In the zero order. Yes, I think zero order. I don't think so. I think first and second order are on the equation sheet, but you can Google the equation sheet. It's all over the place. Any of the College Board things will have. So the only way the zero order is different from first order, and first order is given in your equation sheet, is that's natural log, and there's no natural log here. So practically you have the zero order there too, even though you don't really have the zero order. I think it only gives you first and second order, not zero order. Okay, guys, one more minute. Any other last minute questions? You're welcome, Talia. Okay, I guess that is it, guys. Good night, and I'll see you tomorrow bright and early. All right, get a good night's sleep. You're fine. This is an easy quiz. Bye, elements.